All right, you're going to be taking notes, writing a few things on your own paper. It's the paper titled Parts of an Experiment. So, we're going to be talking about that fourth step, the scientific method, the one that comes after identifying a problem, gathering information, forming a hypothesis, and then the experiment part. So, you are going to be writing on your handout, what is in black will go under the section titled Definition and Purpose. So on the slides, the words that are in black go here. And what is in blue goes under this that says extra information. I have a experiment that's going to be in red. It's already written here for you. So you don't have to write what's in red. It's already here. But just pay attention because we're going to go through like as if we were doing this one experiment. Okay, so at the top of the page that you have, the question that we're trying to answer is typed. It's here in red, and it says, "Does tapping the top of a shaken soda can have an effect on the amount of spray that comes out?" We all have gotten a soda that has been shaken and opened it and it has spewed everywhere. Most everybody has experienced that. Well, some people believe if you tap the top of the can a few times, a less of the spray will come out all over you. So you can actually test that. And this is what we're going to do kind of as we go through all these parts that you're going to need to learn. So we'll start with the hypothesis. Of course, we got the question, does tapping on the top of a shaken soda have an effect on the amount of spray that comes out? And you can use what you know about sodas and your experience with opening up cans, some shaken, some not, to gather information to develop your hypothesis. Now, a hypothesis, you're writing what's in black on the row across hypothesis. An hypothesis is an explanation based on observed facts or an idea of how things work. So you need to write that in that first blank column underneath definition and purpose. That's what a hypothesis is. Some people say educated guess. It is so much more educated than just a guess. So it is an explanation based on what you know, what you observed, what you have researched. It is a educated guess as to the answer. Now, in blue, you're going to write in the extra info, if and then, or I think statements is how the hypothesis should be written. If and then are what we're going to try to do when we come up with a hypothesis. So, for example, after thinking about the question, does tapping the top of a shaken soda can have an effect on the amount of spray that comes out? You might come up with a hypothesis of, if you increase the number of times you tap on the can after shaking it, then the amount of spray that comes out will decrease. In other words, the more times you tap, the less spray. And you can test that with the soda cans. At this point, if you need to pause to get this written down, please do. So this is an example of the tapping the top. So tap, tap, tap. And again, you can change the number of times you tap it. That's what you're going to experiment with. How many times you tap it. And there's a few things you have to do the same in the experiment. And there's a few things, or one thing you have to change. So we're going to talk about that. Okay, so if I were doing this experiment, there would be some things that I would want to keep the same. Like I would use the same brand of soda. You're not writing this, you're just paying attention. I wouldn't use a Coca-Cola, a Pepsi, a Dr. Pepper, and a Sprite because we're not testing which type of soda spews less. So we want the same type of soda. We want to make sure all our sodas at the same temperature. Either they all are the same cold or room temperature. And you would need to shake them this exact same. You wouldn't want to shake one can more than the others. So they need to be shaked the same amount and the same force. Okay. Now, if I'm testing this and I have 5 cans of Coca-Cola that I just shook up, what I would want to do is mark each one with how many times I would tap them. I would need one that I wouldn't tap at all. I shook it up and I'm just going to open it and collect all the spray to measure to see how much came out. So this would get 0 taps. My second can might get 2 taps, and I'm going to increase them, maybe go 5 taps. Then this can gets 10 taps on the top, and this one gets 15. What I'm measuring is what I'm changing. I'm changing the number of taps because, again, I think the more I tap it, the less spray. So if that's true, the one I tapped 15 times would have less spray coming out than all the others. Now, in order to catch the spray, to collect it, to measure the volume, after I shook the cans, I would place them in a baggie. This is my little Ziploc baggies here. And I can open them while they're still in the baggie, and whatever spray comes out stays in the baggie. I can then pour that into a graduated cylinder, and I can measure and see if there's a difference. So let's say we shook them, we opened them, and then we remove the cans, and we can see how much of the soda's left. This is representing the soda. And I could take this again and measure each one of these in a graduated cylinder and see how the volume's different. Now, just looking at this, we could tell it got less and less and less. So let's talk about this. Now, if they would all had the same amount, then I would have proven, well, that's not true. It doesn't matter how many times you tap it. But looking at this, the more you tap it, the less spray comes out. Now, let's talk about the parts. When you're doing an experiment, you need an independent variable. Notice the stuff in red's already on your page. This is sometimes called the manipulated variable. This is what the scientist or the person is testing. You need to write what's in black in the first blank column under definition. The independent variable, this is the variable that is being tested. It is what the scientist changes in each trial of the experiment. We were testing if the number of times you tap on the can had any effect. So changing the number of times we tapped was a more independent variable. We did 0, 2, 5, 10, 15. Now in blue, you need to write under extra info. It is the if part of the hypothesis. If you increase the number of times you tap, that's the independent variable, the number of times you tap the soda can. You can only test one variable at a time. In other words, you can only change one thing at a time. You wouldn't want to change the number of times you tapped and the temperature of the cans. That's why we want this temperature to be all the same. You wouldn't change the soda brand. You wouldn't test a Dr. Pepper against a Coke versus a Sprite. That's why you need all the same soda brands. You can only test one variable at a time because if you do more than one, you won't know what changes the outcome. If you only test one at a time and there's a change in the outcome, then you know what you changed had an effect. All right, so here's the top point where you pause if you need to finish writing. All right, in an experiment, you're going to have a dependent variable. This is also called the responding variable. It responds to what you do on the independent variable. The dependent variable depends on the independent variable. These are your results. So you're writing what's in black under definition purpose. The dependent variable, the results, because of what has been changed by the scientist. It is the factor that is being measured and are your results. Again, we were measuring how much of the spray comes out. We would measure that with a graduated cylinder. That's our results. The volume might change. So it is the then part of a hypothesis. Then the amount of spray that comes out will decrease. So we're measuring to see if that's true. And I have the example, again, the volume or the amount of spray produced by the can when you open it. That's what you're measuring. All right, moving on to constant. Constants are factors that are not changed in each trial. In other words, it's the stuff you do the same to everything you're doing, so you do not affect the outcome. So again, I had the same brand of soda. I kept them all at the same temperature. I tapped them the same. I didn't tap one harder than the other. I tapped them in the same spot. I put them all in the same baggie. So stuff like that, I shook them up the same. Those are things you have to do to all of them exactly the same, so that one of those things, if you do differently, does not affect it, because the only thing you're testing is that independent variable. So in blue, you should write always the same. You can have several constant factors. Like I said, same brand of soda is one. I shook them the same ways too. I kept them all the same temperature. That's the third constant. Fourth constant, I tapped them the same. I just tapped them different amounts or numbers of time. That was the independent variable. All right, pause if you need to. All right, a control. When you do experiments, you need a control. This is the standard to which the scientist compares the results of each trial. It does not have the independent variable added to it. It's the kind of test run you're doing where you don't do anything special to it that you're doing to the others. You don't do the independent variable to it. It still has all the constants, but you do not do the independent variable. Now, in the case of the soda cans, it's the one that we shook up, but we did not tap. We just put it in the baggie and opened it. We did not tap the top, because that's what we were testing. If we tap the top, if it changed the amount of spray. So a control is a baseline used to compare results. So it does not have anything extra done to it, because you want to compare and see if its results were different than all the others. And if they are, then you know what you did to the independent variable, what you did to the test probably had an effect. If all the results were exactly the same, then tapping the can did not matter. Doesn't matter how many times you tap it. Once you've done this, you've written all your results down, that's when you come to your conclusion. If the amount of spray decreased like you thought it would, you might do another test run using maybe a different type of soda, like do all Sprite. You'll do the same thing and you'll test it several times, and then you can come to your conclusion if you keep getting the same results that yes, maybe tapping it does work.